Alright, so today I'm going to show you how to solve a linear equation with one variable graphically. And then I'm going to show you how to do it numerically and analytically, but first we're going to start with graphing. Alright, so the first part of this equation is to find out what the parts of the equations are. So this part is the y1 of the equation, the first part of the equation. This is the y2. The first part and the second part. Now let's plug these into a graphing calculator to find the values. So in y1 we will plug in 3x minus 2. In y2 we will plug in negative 8. And when you enter, when you press the graph button here, it's gonna graph the equations and the parts of them, and you will find out that the point of intersection on this graph, if I can just find it real quick, is -2 and -8. It's supposed to be there. I'm not exactly sure how I'm going to put it there, but it's -2, -8. So the x is -2. So if we look back at this equation and plug in -2, it should satisfy the equation. So 3x minus 2 equals -8. I'm just going to redo the equation so to make this easier. -8, and then put an x with 3, -2 minus 2 equals -8. So 3 -2 is -6, minus 2 is -8. So it satisfies the equation. So that is how you solve a linear equation with one variable graphically, and now we're going to move on to numerically. It's time to solve a linear equation in one variable with a table of values. So we're doing it numerically. So in this situation, you kind of want to get the easy, easy numbers out of the way. So like -2, -1, 0, 1, and 2. Sorry if this is a little slanted. I'm trying to find a way to do this without interfering with my line of sight. So you want to -2, so basically you want to plug in -2 into -3, and then +1. So -3 times -2 would be 6, plus 1. So -2 is 7, and 1, -3 into -1, which is +1, which is 4, plus 1, which is 5. So if you notice the trend, it is going down by 2. So if we do the same thing here, it's going to be different, because if you're plugging 0 into -3, you're going to get 0. So in that situation, this would just be 1. 1, -3 into 1, plus 1. So -3 plus 1 is going to be -2. 2, 3, negative. Okay, let's do it right here. -3 into 2 plus 1. -6 plus 1, so it's 5. So this is our table of values. Now, you would plug these points into a graph if you were to do it graphically, or I think it is graphically. So in this situation, since we are just doing it numerically, since we have got our table of values, we are basically finished. Now the next method I will be doing it is analytically, which is the normal algebraic way, which in my opinion is probably the easiest way to solve a linear equation in one variable. Alright, so last but not least, we will be solving this linear equation in one variable in analytic fashion, which is just normally algebraically. So it's pretty simple. The first thing you want to do is get 3x on the other side. -3x minus 5 equals 4. Then you want to get 5 to the other side, plus 5. -3x, so I forgot to put an x here. -3x equals 9. Sorry about that. So -3x equals 9. Pretty easy to solve, It's just x would equal -3. So this is extremely easy algebraically, because solving a linear equation with one variable is as easy as it gets. In terms of other, if you were to do it with more variables, it would become more complicated. But this is the simplest way to solve a linear equation in one variable. And after this, you would just plug it in to make sure it is correct. So let's see. Since we -3 equals 9. -3 times -3 does equal 9, so 9 equals 9.